Cramer's rule can also be applied to solve larger systems of equations. We can solve 3x3 systems with Cramer's rule. To solve 3x3 systems, you're just going to need bigger determinants. Okay, the denominator is still the coefficients. So I'm just taking the numbers off the x, y, and the z's in each equation. And it's going to be the same over here. It's going to be the same on the z. Okay. Now, the numerator of each of these follows the exact same pattern as it did for the 2x2 Cramer's rule problem, in that these numbers, the 0, the 7, 11, these numbers go in where the x's go when solving for x. They go in the middle where the y numbers are when solving for y, and they go in on the right where the z numbers are when you solve for z. And I just fill in with the other numbers from the coefficients as they are. You're going to find that the real work in this is probably just setting it up. There's the setup. Now, each of these 3x3 determinants, if I do without the calculator, require me to take the first two columns behind here, go through all 6 of those diagonal products. It's a lot of work. I'm going to use the calculator to speed this up considerably. I'm going to call this matrix A, I'm going to call this matrix B, this matrix C, this matrix D. I'm going to type in 4 matrices into my graphing calculator. Okay, if you are ready, go ahead and resume playback. If you're still typing in all these numbers, then you can keep typing it in, just hit pause. But I'm ready to go, so I'm going to go ahead and show the final solution to this on the calculator. For the x, what I want is the determinant of A divided by the determinant of B. I'm going to do that right here, all of it right here. So I'm going to go into matrix. I want determinant. Whoops, that's not what I want. I want determinant of A, close parenthesis, divided by, go back in, determinant of D. So this is 0. Okay. And I'm going to go back and I'm going to do all of them that way. So I'm just going to copy this. Going to replace that matrix with B. So now I have determinant of B divided by D. And that's 2. copy that. I'm going to replace the B with matrix C. So I'm going to go in matrix C, and that's 1. So I got 0, 2, 1. So I got x is 0, y is 2, z is 1. That's not too bad. If you get pretty proficient at the calculator, you can type all those in real fast and run through those determinant calculations, and it's really super fast. The challenging part is the setup here. Once you understand the mechanics of the setup, it's really not a hard problem at all. The last thing I want to show you for determinants is that they can be used to find the area of a triangle that is superimposed on a coordinate plane. Let's go ahead and label these points. Call this x1, y1. Call this one x2, y2. Call this one x3, y3. The area of the triangle is equal to plus or minus 1/2 times, I'm going to go with x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay, so we find the 3 by 3 determinant, and we take it times plus or minus 1/2. The reason why the plus or minus sign is there is to force the answer to be positive. If this determinant comes out to be a negative number, take it times negative 1/2. If this comes out to be a positive number, take it times positive 1/2. Therefore, you always get a positive answer for the area. Directions say find the area of the triangle graphed below. First, we need all these ordered pair points. This point is 2, 8. This point, 1, 2, 3, 4, 5, 6. This one is 6, -8. And this point looks like -8, -1. Okay, so our area is plus or minus 1/2 times, and the points can go in any order. That doesn't matter how the points go in as long as they are x, y, followed by a 1. X, y, followed by a 1. X, y, followed by a 1. Like that. Okay, I'm going to do this 3 by 3 determinant on the calculator, just because I think it's faster to do them on the calculator. So let's show that. I'm going to go to matrix, I'm going to edit. I want a 3 by 3. It is 2, 8, 1, -8, -1, 1, 6, -8, 1. Quit out of that, and I go back to matrix, over determinant, back to matrix. There's its determinant, 196. So the area is equal to 1/2 times 196. So 1/2 of 196, the area is 98 square units.